All right, boys and girls, let's talk ratios. By the end of this lesson, you will be able to define the term ratio, state the ratio of given scenarios, identify equivalent ratios, and also simplify ratios. The question is, what are ratios? Well, ratios are like fractions. They show relationships between numbers, sets, or parts of sets. Ratios can be used to compare two sets of data or numbers. Ratios can also be used in numbers and amounts. We use ratios in everyday life. Take, for example, this photo. The ratio of diamonds to hearts is 3 to 5. We write that by saying 3:5. The order in a ratio is very important. If we were to write this ratio as 5:3, we would be incorrect. But the question is, why? Well, think about it this way. If you were mixing an orange drink from concentrate, suppose the instructions say that you need 1 part concentrate to 3 parts water. This is a ratio of 1 to 3. This means that you will pour 1 cup of orange concentrate and 3 cups of water. 1 part concentrate, 3 parts water. This will give you the correct mixture and a nice drink. However, if we were to mix 3 parts concentrate and 1 part water, our drink or beverage would not taste very nice. It might even be too tart, or as some people may say, too sour. That's why it's so important for us to follow the order of the ratios. Also note that ratios do not have units. This is because the proportions are fixed, so the ratios work for any unit. 3 cups to 7 cups, 3 bags to 7 bags, 3 tons to 7 tons. There are 3 ways to write ratios. Let's take a look. Here you can see we have some colored circles. What is the ratio of orange circles to blue circles? We can write this ratio using a colon. We can write this ratio using the word 2, or we can write this ratio as a fraction. So there you have it, the 3 ways that we can write a ratio. Now remember, like I said before, the order of the ratio is very important. The ratio of orange circles to blue circles is 3 to 2. How do we know that? Because they asked us for orange circles first, so we write the number 3. Then they asked us for the amount of blue circles, so we write the number 2. 3, 2, 2. What about this? What is the ratio of apples to pears? Remember, the order of the ratio is important. That's correct. The ratio of apples to pears is 6 to 3. How do we know that? Well, there are 6 apples and 3 pears. 6 to 3. What about the ratio of apples to oranges? Wonder what it could be. Think hard. You guessed it, 8 to 4. How do we know that? Well, even though there are more than just apples and oranges in this photo, we are only making mention of what we were asked. We know that there are 8 apples and 4 oranges, so the ratio is 8 to 4. What about in this photo? What is the ratio of stars to red circles? Think about it. That's correct. 4 to 7. How do we know that? Well, there are 4 stars, and if we count those red circles, we would get 7. Remember, the order of the ratio is important. What about this? Look carefully. What is the ratio of triangles to squares? Triangles to squares. 9 to 3. That's correct. How do we know that? Well, there are 9 triangles and there are only 3 squares. So the ratio of triangles to squares is 9 to 3. Let's look to see how we can simplify these ratios. Ratios can be easily simplified just like fractions. To simplify a ratio, we use the operation of division. Divide all of the numbers in the ratio by their highest common factor. Let's look at this example. If we wanted to simplify 6 to 12, what would we do? Well, first we identify the highest common factor or greatest common factor of both 6 and 12. When we do that, we would note that that number would be 6. 6 is the greatest common factor. Next, divide both 6 and 12 by the GCF of 6. 6 divided by 6 is going to give you 1. And 12 divided by 6 is going to give you 2. Therefore, 6 to 12 when simplified is equal to 1 to 2. Let's look at another example. Simplify 10 to 55. First, we must identify the GCF or HCF of both 10 and 55. That would be the number 5. Next, we divide both 10 and 55 by the GCF of 5. 10 divided by 5 is going to give us 2. And when we divide 55 by 5, we end up with 11. Therefore, once simplified, 10 to 55 is 2 to 11. Let's take a look at equivalent ratios. Two ratios that have the same value are called equivalent ratios. To find an equivalent ratio, multiply or divide both quantities by the same number. It is the same process as finding equivalent fractions. Let's look at the ratio 3 to 4. To find an equivalent ratio, we multiply or divide. Let's multiply. So we are going to multiply 3 and 4 by another number. Let's try the factor of 6. If we multiply 3 to 4 by 6, we get 3 times 6, which is equal to 18, and 4 times 6, which is equal to 24. So, 18 24s, or 18 to 24, is equivalent to 3 to 4. Let's look at another one. Suppose we have the ratio 10 to 15. Again, we are going to either multiply or divide. In this case, we'll use the operation of division and divide the numbers 10 and 15 by another factor. Let's divide by the factor of 5. So, if we take 10 and divide 10 by 5, we're going to get, that's right, 2. And if we take 15 and divide 15 by 5, we are going to get 3. So, 2 to 3 is an equivalent ratio for 10 to 15. Now let's review. Remember, boys and girls, that a ratio is used to compare numbers. We can write ratios in 3 different ways. To simplify a ratio, divide both quantities by the same factor. To find an equivalent ratio, multiply or divide by the same factor. Once again, this lesson was created by Miss Antonia Bain.